So guys, lesson 6.4 is all about accumulation functions. And before that, can you write this in parentheses? FTC.
No.
FTC. So what do you mean by FTC?
Like reacts.
Fundamental Theorem of Calculus. So again, what is FTC? Fundamental Theorem of Calculus. So we have
What does he say every time? FTC. My team's there. It's November. I'm a slimmer.
Okay.
Sober. It's October.
So, Alonso, can you read the first two paragraphs?
Last season we learned about the definitive integral. What is that thing called?
From the summation from A to B, or the integral from A to B?
f of x dx represents the area under the curve of f of x on the interval AB. Let us say we know the interval starts at A, but we do not know where it stops. That would give us A to B, where A is constant and x is some unknown variable. We can represent the few new functions that would look like this.
Okay, so it says right here, the interval starts at A, but we do not know where it stops. So the lower limit is given, but we don't know the upper limit where it starts. Stops, right? Hello, listen. Okay, so which means we're gonna have the integral from, let's say, from A. A is the the lower limit, and we don't know the upper limit, so we say x. Okay, we don't know, which means if our A right here, from this graph, if our A is 0, and then the interval could probably be from 0 to 1, and that's the x, okay? Or the interval could possibly be from 0 to 2, okay? Or it could be from 0 to 3, or 0 to 4. That's the meaning of x right here. Whatever is the lower limit given. Probably you are given an interval from 1 to 4, okay? Now, we have the f of x, or f of t, dt. So, is this clear, guys? Again, the lower limit is given, but we don't know yet the upper limit. So let us say your lower limit from this graph, say from 0, and you're told that your x would be, you're told to solve for the area from the interval 0 to 1. You get me? Or from 0 to 2. That 1 or 2 or 3 or 4 is the x. That's the upper limit. Is this clear, guys? So you have the formula f of x is equal to, this is capital letter F, okay? And this is the small letter f right here. So we say now f of x is equal to the integral from a to x f of t dt. Whatever is the variable right here would also be same variable. If this is f of s, this is ds. If this is f of x, this is dx. Clear, guys? So you need to be consistent. Okay, so we have given us the interval from a to b, where a is constant and x is some unknown variable. We can represent that as a new function that looks like this. So this is the new function. Okay, can I move this up now? I need the space for this problem.
And I want you to be my
Okay, so problem number 1. Let f of x is equal to the integral from 0 to x f of t dt. Use the graph of f. So this is the graph of
F.
f. And then in the figure to find the values on of the table on the interval from 0 to 5. So from 0 to 5. Okay, 1, 2, 3, 4, 5. Now look at this. It says f of x is 0. F of x is 0. From there, we're gonna have the integral. I'm gonna have this one. F of x is 0. That means 0 to 0. Do you get me? Because we're gonna have the starting, the lower limit 0. Implies that f of t dt. Okay? What is f of t dt? Do we have value of the function? The function is also nada. 0. Okay?
Zero.
Next. How about this one? F of, so as I said, start at 0 to 0, then next 0 to 1, right? Because this is 1.
Yes.
The interval is from 0 to 5. So let's say f of 0 to 1. F of t dt, which means f of 1 dt. What is f of 1? Look at this. So it's gonna be area, accumulation of area from 0 to 1. Do you get me? So by looking at this, for the sake of discussion, I'm gonna shade this from 0 to 1. What area covers? This is the entire area covered from the interval 0 to 1. Do you get me? Can you count the number of squares? The shaded squares. Can you count the shaded squares? 2.5 or 2.5, right? 2.5. Okay. So I'm gonna fill this up first. F of x is 0. And then at f of t, t is equal to 1. So the area is 2.5. So it's now an accumulation of area. Do you get me? Next, how about from the interval 0 to 2? From the interval
4.
0 to 2.
4.
Okay, where? Why?
Because it's 1.5 and the 2.5.
Okay, can you come and then show it to them? Show it to the class.
I got you.
You said come?
So right here, it's 1, and then another half. So half plus half is a full.
Okay, then plus the 3 squares.
Exactly.
Okay, very good. Shall we give Chris a round of applause? So, which means from 0 to 2, f of 2 is equal to, f of 2 dt is equal to 4. And a question where we get 4. How about from 0 to 3? Interval from
5.
0 to 3.
5.
Money
5.
from 0 to 3.
5.
It's gonna be 5. You're gonna include this again, the square. Okay, another square. So the accumulation now of the area from 0 to 5. How many units are there? How many squares? 1, 2, 3, 4, and then half and half. That
5.
makes 1. So 4 plus 1 equals 5. Clear, guys? Can you continue? At 4, what is the accumulation of the function now? It's gonna be 5.5. Why?
Because there's an extra half.
There's an extra half.
Square.
Okay, right here, this is half. So this means 5.5 or 5.5. Can you continue writing this right here on the side? Can you continue writing here on the side? And then, how about at 5?
Negative half. So it's 5.
Now, the area at 5 right here from 4 to 5 is below the x-axis. That means this is what? Positive or negative? Negative. So, what do you think is the area from the interval 0 to 5? It's gonna be 5. Okay? Now, look. Look at this. Now, that means this is the graph of f. And this is the function f of x. Look at this one. I'm using red color. If x is 0, the function is 0. Okay? What about if x is 1? What is the function? 2.5. Meaning that's the value of y. If x is 1, y is 2.5. Look at this. It's 2.5 right here. Okay? Next, if x is 2, what is y? What is the function? If x is 2, we're gonna have 4. Look at this. 1, 2, 3, 4. Okay? 4. The height. Remember, last time, if we do area of a rectangle, it must be the length times the width. Right? Okay. Next. How about if x is 3? If x is 3, it's 5. So right here. Okay. How about if x is 4? It's gonna be 5.5. Do you hear me? 5.5. So let's just estimate that 5.5 lies here. How about if x is equal to 5? It's gonna be 5. So right here, it's gonna be 5. Well, you notice on that discrete graph, parabola. Okay? That means we are doing the area. And this is now an accumulation function, right? And this is also called as the fundamental theorem of calculus, number 2. Okay? FTC 2, part 2. Why is it, Mr. Roy, that we jump right away to part 2 without passing part 1? Now, for you to understand the part 1, we're gonna have to do part 2 first. What? Okay? Because most of the time in part 2, we are on the graph of parabola, whatever. Okay? So, is this clear, guys? So, this one is now called as accumulation function. Okay, can you write down the word accumulation function? Can you write down also part 2? So, fundamental theorem of calculus part 2. If A is a constant and F is continuous, what does it say for the function? It is a continuous function.
No.
Okay? Continuous function. Like from the table, continuous from 0 to 5, and you have this. Okay? The function is continuous. If you graph that one. Now, look. If I graph this also, this is discrete. Is this continuous? Yes, no. It is, right? Okay. So, I move this out a little bit. So, we say now that given would now be f of x dx. So this is the f of x. So, derivatives and integrals are inverse. Again, derivative and integrals are inverse. Because if you say derivative and then antiderivative, it is the inverse. Remember, last time I gave you an example. If I have a glass right here, I'm holding a glass, and I'm gonna drop the glass, what happens to the glass? It disintegrates, right? So that's differential. Okay? Derivative. Then my next concern is I have to put it back to its original shape. So what is that? Antiderivative. And that is now integration. So we're gonna continue the discussions tomorrow, guys.